See, last week we started introduction of PySpark. In that we already discussed at high level what exactly is a Spark and what are the features, and also components we discussed. Like let me open components. So these are the components that we discussed, and prerequisites what we supposed to know to learn PySpark. Okay, then today we will focus mainly on Spark architecture. Okay, these are very important. I will try to give some definition for it. Okay, definition in a sense we can directly refer a Spark documentation. Definitions we will get it from here. Let me go to documentation part. See, these are the meanings. Okay, what exactly is the application? Let me go. Let me walk through some of definitions so that when we discuss in our architecture part, then that is very useful for you. Okay. So Spark application is simply it's a user program, and it consists of driver, driver and executors, etc., right? So that is generally we create a jar if it is a Spark with Scala, or if it is a Python, then we simply use .py file so that we can call it as a Spark application. Okay, and driver. Okay. So driver is again it's a process to run the main function of the application. Okay. So what is the use of this driver is mainly it creates Spark context. Okay. And there are many other important tasks are there which will performed by driver program that I will try to tell you. Okay, when we discuss architecture part. Okay. And anyway, cluster manager, cluster manager, we have a, presently standalone is there, Mesos and Yarn Kubernetes. Okay. So, and guys, I think if I explain this, then you may get some doubts. So let me first of all go through the main part of the lecture so that as part of that explanation, automatically this will come. Okay. If you see diagrammatically, you will know, you will have more clarity, right? Okay. First of all, what we will do at a high level, we open this diagram. Okay. So this is the Spark architecture, right? Like when we submit an application in a cluster, what will happen? This is our today's topic. Okay, so I will give you in depth in this lecture only. Please try to follow. I read many blogs or YouTube videos there. This topic is very confusing. Okay, even you learn now, many people are saying more than 8 steps or 10 steps. Okay, those are mandatory, but thing is, if you learn in a theoretical way, right, definitely you will forget after 1 week or 1 month. Definitely I believe you won't remember all these things, steps, right? So instead we'll discuss in a practical manner with a very limited steps. Okay, why I'm saying nobody will ask you when you start working in a Spark, okay, in your company, but thing is in interview, okay, definitely people will ask, okay, what is the Spark architecture and what will happen when we submit any Spark application inside? So these are the very expected questions, and we have two advantages to learn this subject. One is in interview we can able to answer it. The second one is very good knowledge on Spark internal architecture. Okay, it always help us to build an application and run application on a cluster. Okay, so two ways we will get the advantage of this. Okay, so when we submit an application, okay, I mentioned we can submit an application cluster mode and client mode. Okay, if you don't know difference between cluster mode and client mode, I have a dedicated video in our channel. You just go through it. you can definitely understand what is that cluster mode and client mode. I can say when we submit an application, if application creates a driver inside the cluster node, okay, then that is called cluster mode of deployment. If not, if we submit an application, but driver program or driver will create outside of the cluster, that is an edge node or client node, then that is called as a client mode of deployment. Okay. Anyway, for practicing purpose, for debugging purpose, we can run our applications in a client mode, but in real time, most of the cases, people will run application in a cluster mode. That means driver program will be created inside the cluster. There is a reason, right? Why people, in a production, why we used to go for cluster mode is because high availability. Okay, if something goes wrong outside of the node, then it is very difficult to retrieve the result of the application, right? When we submit any job. But when we run the same in a cluster, the cluster is very rare cases to down. Okay, and there are multiple nodes in a cluster. Okay, it goes down, then automatically one more node will take care with the help of cluster managers. Okay, so that is the reason people most prefer cluster mode of deployment. All right. So before deep dive into the subject, right, this topic, to understand better, first of all, we have to know what is worker node, what is executor, what is cache, what is task, what is stages, and all this terminology we should familiar, right? Okay. Yeah. Please try to understand this. Please try to understand. Okay. This I did my own, whatever I understood from the Spark documentation. Okay. See here. This we know very well, right? What is this? This is a worker node, or a node we can say in a cloud terminology, which is a virtual machine, right? So a machine or a computer is definitely have some OS and some cores and some memory, right? Okay. So let us assume, let's understand first what is container. Okay. Container is nothing but it's just allocation of memory and CPU in sense core and memory. If you see this box, I clearly mentioned this is a container. We can say the container is a just a virtual term that we given a name as a container. Okay, because every time we may not refer core and memory, right? That instead we are giving one name called container. Okay, what container will do? It will allow a user code will run and execute the results. Okay, that means it will execute particular task which assigned by the driver program. Okay, now every executor, okay, executor is nothing but again containers, right? Okay, container is outer part is executor. In executor, each executor is having its own JVM. Okay, and what is executor? If you see this this box, you come to know what is executor. Okay, we no need to have a separate theoretical discussion, but still, okay, it's a instance of a JVM, right? Executor is an instance of a JVM where it will execute the task. That's it. That is the meaning of the executor, right? And each executor is having separate on heap memory, okay, and okay, and cores, and then memory it's a regular memory and JVM. Okay, you just think like that. This we are calling it as an executor, right? We can say this worker node is having 16 cores, okay, and 64 GB RAM, that is memory. Okay, so let's assume 2 cores and 4 GB is for OS. To run a machine, we need OS, right? For that, memory is required, right? So leave it about that. Out of 16 core, 4 core used by the mission. Okay, it's internal purpose and 4 GB RAM. Then how many cores are left? 12 cores are left. Okay, and then how much memory is left? Again, let us say 60 GB. All right. So that 12 cores and 60 GB, again, executor 1 has taken, let us say, 6 cores and 15 GB, sorry, 30 GB, and executor 2 has taken the similar way. Okay, 6 cores and 30 GB. So just think like that. It's not exactly the same. To understand better, I'm just giving an example. All right. So system OS is also having some off-heap memory. What is meaning by on-heap memory or off-heap memory? First of all, we have to understand this concept. Okay. On-heap memory, off-heap memory is very simple. That is executor memory that lies within JVM is called on-heap memory. Okay. Executor memory that lies inside the JVM, okay, is called, or executor we can say, is called on-heap memory. Okay. And the executor memory that lies outside the JVM is called off-heap memory. That's it. Here, simple thing is this on-heap memory will be handled by whom? JVM. JVM is handling on-heap memory, whereas off-heap memory is handled by OS. All right. So these JVMs won't handle this half-heap memory. Okay. OS will be handling off-heap memory. Okay. Why we use this half-heap memory? We will discuss. Okay. Whenever we go into that depth, definitely we will try to use discuss in detail. Okay. But try to understand this terminology by seeing this diagram. Okay. So when we submit an application, right, we have to explicitly mention, on-heap memory, off-heap memory, whether it is required or not, we have to mention as a parameters. Okay. That we will discuss later, but try to understand what will happen when you submit an application. Okay. The moment I say executor, you should you should understand this way. Okay. Because in a simple, right, here, if I say executor, definitely you won't get a much knowledge. Okay, much clarity. That is the reason I just showing a different diagram so that you can understand better. All right. So now first step, what will happen? And I want to add one more point to go actually main topic. What exactly internally happen when we submit any Spark application. So what driver will do is, whenever we submit any Spark application, okay, it will divide that entire code or application into subjobs. Okay, here I just represented only 2, but in real time maybe more. Okay, so it will divide into subjobs. Again, subjobs will be divided as stages, and again the stages divided into tasks. Okay. Just try to understand at high level. When we are going to execute any program, then we will see practically. Okay. As of now, just keep this point in your mind. Okay. Simply, Spark application will be divided into further steps like subjobs, stages, and then tasks. Okay. This is the responsibility of Spark driver. Will do all these processes. Okay. And coming to core concept. Okay. Spark architecture. As part of Spark architecture, this is the diagram which got from Spark official documentation. Okay. So what will happen when we submit a Spark application in cluster mode or client mode? When a user submits Spark application in a cluster mode, then Spark will launch a driver inside the cluster on any one of the data node. Okay. If you see this application or this diagram, okay, Spark launch the driver inside the cluster. Since let us assume this is a cluster, whatever I drawn rectangular, let's assume this is a cluster. Inside the cluster, this you can assume this as a data node. Okay. So Spark will launch a driver inside the cluster on a data node. Okay. If it is in cluster mode, I mentioned cluster mode node. In client mode, driver will create outside of the cluster. Obviously, in our wherever we are submitting application, that I can call it as a client node or edge node. Okay. You just Google it, what exactly the edge node, or you just go to my previous videos, which was uploaded. Then you come to know what exactly is the edge node or gateway node. Okay. Meaning of that, right? This is the first step. Okay. Simple is when we submit an application, it will create a driver program inside the cluster and any other data node. Okay. Next point. Then what driver will do? Immediately driver will create Spark context. Okay. And a separate JVM. So driver will create Spark context or Spark session and a separate JVM in driver or in data node. Okay. Where driver resides. Right. Then third. So once Spark context created or Spark session created, it will connect to the cluster manager and try to get the resources. Resources here is nothing but a executors from a resource manager. Resource manager is a master or processor in cluster manager. Okay. So resource manager will allocate resources to the to the driver to execute the task. Then when driver or cluster driver or Spark context acquires the number of executors, that immediately those a number of executors will be registered with driver, right? Then only driver come to know, right, how many executors are working, something like that. So immediately all the executor whoever assigned for this application will be registered with driver. Okay, that is the third step. And the fourth step is, see, the third step is mainly handled by Spark context, right? But meanwhile, what driver will do, driver will convert user code, whatever we submit a code, right? It will convert that code into logical DAG, and then based on that, it will create a physical DAG. Based on this lineage or directed acyclic graph, it will finally create a task. If you remember previous slides, I told you, right? First of all, finally it will create task. So this is how it will create. Don't worry about what logical DAG or what physical DAG. We'll see when we try to execute a real-time program. Okay. Meanwhile, you try to please note this point in your mind. All right. So obviously, if you think this is little hard to understand, then complete this is in one single step or sentence. Driver will create a task. That's it. That is a simple step, right? And fifth step, as and when driver creates a task, number of tasks, then Spark context sends all tasks to the executors, right? Then what driver will do? Driver will distribute all the tasks and schedule the task for execution on the executors, right? This is the fifth step. Final step is sixth step. What will happen? Driver will keep the track of all the executor running status and get the result from them, right? Once execution completes, then that result will move to driver, right? And next is, on successful completion of all the tasks, executor will unregistered with driver. That's how it ends. Okay. Whenever you face this question in any interview, you explain these 6 steps. That's enough for my knowledge. If they ask you internally, what is cluster manager? Cluster manager again have the resource manager and application master. Okay. So what it will do, a resource manager responsibility is to allocate resources like executors to driver. Okay. That is the resource manager responsibility. What application master will do, it will just maintain or manage the status of the application. Okay. If something goes wrong, okay, it immediately will inform to cluster manager as well as driver. Okay. That is the application master responsibility. But this, I can say, you won't discuss these points. Okay. Because this is a little deeper, right? They won't asking you what exactly the cluster manager will do. If cluster manager specifically they're asking, then only you can specify resource manager and then application master, but they are not asking specifically, then you don't discuss. We have to understand that here, who is the hero of this cinema is again driver. Driver is a heart of that application. Try to understand. So what it will do, it will analyze, it will create a DAG, or it will do a task, okay, and it will distribute the task into executors, okay, and it will schedule the task, right? Task is a unit of work that will send to an executor. Task, what is task? It is a general term, right? It's simple. It's a unit of work. Okay. What is the job? Job is a parallel computation consisting of multiple tasks. Okay. It's mainly they're saying for parallel computations. Okay. Each job gets divided into smaller set of tasks called stages. That's it. Okay. If you see this diagram, sorry, this one, you can understand. So typically, when we submit any application, Spark application, then internally driver will do this exercise. Okay. So this is called, we can say, DAG. Okay. It will create a DAG, something like this. Okay. And it will create the task out of it. Okay. It will segregate tasks like this. And all this task will be sent to our executor, right? Our executors. Okay. So each container, what will happen? It will take the task and execute here. Okay. Execute here by using all the scores, memory, on heap, sometimes half heap also. Okay. So driver, again, what I want to say is driver is dividing into subjobs, stages, tasks. Okay. And it keeps track of what? It keeps track of which executor is running and which task. Okay. And whether assigned tasks have successfully completed or failed. Okay. Or whether the executor is free or assigned by some other task or not. Okay. And finally, once it get the result from the executors, it will send back to Spark user, right? So majority of the task will be done by driver. Okay, right, guys? If you have any questions, I'm open because we have 7 minutes left. I know sometimes I may little faster, but try to understand, concept. Okay, hope it is clear. Still, if you have any questions, please try to ask me. Please say your name and let me know. You can ask me any silly question. Okay, don't feel this is a real time training session. Don't feel like that. Feel like I'm a friend of you. You can discuss. Even it is silly, it's fine. We are all learning.
Yeah, yes, Naresh, Nagababu here. Yeah, I heard about partitioning and where we can do that partitioning.
See, I understand your question. Partitioning will discuss a separate topic. Okay, how a job will be divided into partition, because see, nobody will question like that. Like when you explain this, they won't ask you this question because partitioning will happen. How it will happen, we will see. Okay, going forward. Okay. Try to understand high level what happens internally. Okay. What Spark will do is the today's topic. Okay.
Okay.
Yeah.
Yeah.
Yeah. My name is Shushankar.
Yeah, sure.
Naresh.
Yes, there.
I have one question. Could you please explain half heap memory?
Okay, sure. See, Shiva, generally, all of you, we already have we know virtual machines or we know nodes, right? Nodes are nothing but virtual machines. That means are like our PCs, personal computers, right? So,
okay.
Even in OS, right? OS will consume some memory and some cores, and every virtual machine will have separate half heap memory. What is half heap memory is Off-heap memory is a memory which will managed by the operating system. Okay, nowhere it is a part of executor. Okay, it acts as a common to all the executor, because we can say this is a private property, or sorry, public property we can say. But inside whatever on-heap memory we are seeing here, executor 1 and 2 are private property to that executor. Okay, so on-heap memory is a memory which will managed by the JVM. Okay, off-heap memory is a memory which will managed by the virtual machine OS. Okay, so whenever we submit any PySpark application, sometimes we used to give the settings. Okay, I think by default this half-heap memory it is false. Okay, it won't use half-heap memory by default, but explicitly we supposed to mention half-heap memory to be used. Okay, and there is a difference between this on-heap memory and off-heap memory. We will discuss, I think, in our next session what exactly it will do. Or else I will just give you some theoretical what exactly is the difference between on-heap memory and off-heap memory. I already given definition. On-heap memory is the memory which the executor memory that lies within the JVM. Okay, and off-heap memory is a memory which lies outside of the JVM, which will handled by the OS. Okay, so data stored in the format of Java bytes, that means deserialized mode. On-heap memory, right? I think you people know what is serialization, what is deserialization. Whenever if we execute any task, right, data should be deserialized, right? Then only the task will be executed. Okay, so whatever the data which is inside the executor memory, okay, is in the form of deserialized mode. That is, it is in Java bytes mode. Okay, so we can say it is a ready-made food where we eat directly. That is a deserialized mode. If the data is in deserialized mode, that is, it is ready to eat. Okay, that is ready to execute. But the data is in serialized mode, that is array of bytes, the form of array of bytes. To process it, we can say a raw rice. To cook, we have to cook, and to eat, we have to cook it, right? Right? That means it will take some time to cook and to eat. Okay, that is in a if data is in serialized mode, that is in a raw format, then it is not ready to eat. That means it will take some time to convert serialization to deserialization, and then it will process it. Here, it will take little time. Why I specify this point is, this half-heap memory, right? Data, which is, if we use half-heap memory, data will be in a serialized mode. Okay. And to process the data, it will take little more time than compared to on-heap memory. So here, what I want to raise the point is, we have to note it down that on-heap data process in on-heap memory is bit faster than off-heap memory. Okay, but don't think it is very slow. No, it is very fast, but compared to little, there is a little variation. Okay, it will take little more time when we process, data in off-heap memory. Okay, and I want to cover one more point. There is a garbage collector point. Garbage collector. Okay, generally garbage collector is available in on-heap memory, but in off-heap memory, garbage collector is not there. Somewhere I read in a documentation. I just want to highlight here, okay, so that you people have a clarity. These are the differences between this on-heap memory and off-heap memory. When we'll use on-heap memory, when we'll use off-heap memory is depends on our requirement. We can submit, while we submit application, right? We have a separate configurations like parameters that we supposed to pass on-heap memory, off-heap memory, something like that. Okay, there are some points. Okay, and so by default, I told you, right? By default, off-heap memory, it is in, we can say, off, I can say false. There is a command to enable this off-heap memory so that our executors will utilize those memory also whenever it requires. There is a command called set spark.memory.offheap.use is equal to true. This is the one setting we generally use to enable off-heap memory. Is it clear, Shiva?
Yeah. Thank you.
Guys, any questions? Is it okay if I explain like this?
Yes, okay.
Yes, sir. So.
Yeah, yes.
Right.
Naresh, Nagababu here.
Yeah,
I have, some silly question, I think, but I want to ask. Yeah, here we are talking about worker nodes only, right? And in the sense data nodes only. Okay. What other node, data and master node, right? Name node will be there in Spark. Is there any role of name node?
No, I think, do you know Hadoop?
Yes, but not in depth. That's the reason.
Right. I think I want to cover Hadoop also before this, but majority people requested me to start Spark. So that is the reason I came into here. But in Hadoop, right, name node, right? So in a cluster, as usual, we have a name node and data nodes. Okay. So try to understand name node is useful only when to get a, we can say in Hadoop, there is a concept FS image and edit logs. Okay. Based on the FS image, where that blocks got stored. Okay. Where that blocks. Okay. So you're writing some code. Okay. To, let us say one file you stored already. The file is in HDFS. That HDFS address is stored in a FS image in name node. All right. Now that file divided into 3 blocks. Now you in the cluster, let us say we have a 11 node cluster. In 11 nodes, one node is for a name node. Of course, name node 2, 3 we will have a active name node, passive name node, something like that. But try to understand in a simple way. And one is edge node and 9 are the data nodes. You can say 10 are the data nodes. Okay. After 10, we can call it as a one of the node as a edge node, where we submit our application. Because if the cluster is 11 node cluster, our company people won't allow us to use data node directly, right? You correct?
Yes.
So
correct.
They will call it as a one of the node or 2 nodes. They will call it as edge node 1, edge node 2, and they will give an access to use only those nodes to connect the cluster. Okay. Now, when we submit any application on any of the edge nodes, here edge node 1, then it will go to cluster. How many clusters? Total 11 are there. Out of 11, one is none. Immediately, because but you given the path, that path it will go to name node and get it right. There is a metadata, right, maintained by the name node, where master services will run, right? So that name node will provide, by seeing FS image, it will provide the address of the blocks. Then what will happen? Immediately, the code, the driver program will send this code to the particular blocks where those are particular executors are executor or worker nodes where blocks are resides. You got it?
Yeah.
So nearest, right? In the concept of in Hadoop, we have a replication factor, right? Or in blocks. So it will send the nearest worker node first. Okay, if that worker node having block of data, and again it will check in that worker node containers are available or not, resources are available or not. If resources are available, first preference it will give that worker node only, which is nearest to the driver. You're getting me? And driver also, you may have one question. Okay, how Spark create a driver, and which data node Spark choose to create a driver? This is a very, very important question. How many of you understand this? You're getting me? Guys, did you understand what I'm asking? My question is, how Spark knows out of these 10 data nodes, where it will create? Why it is supposed to create, let us say it created driver in data node 1, but my data is there in data node 10. All the way, data is supposed to send from driver data node 1 to data node 10, right? Or sorry, data means code. Code supposed to send data node 1 to data node 1 in a sense, like let us say edge node or data node 1. Here there is a shuffling, right? A lot of shuffling, right?
Yes.
Once executor completes his execution and sends results to driver, then it travels from data node 10 to data node 1. Let us say there is a huge gap or a huge distance between data node 1 and data node 2. Then unnecessarily it will create some consumption, right? It will create some latency, right? Delay, right?
Yes.
What it from Spark is a intelligence enough. It will try to pick the nearest driver node, data node where it has the blocks, and nearby data node it will create a driver. Got it?
Yes, got it.
Yes, that is one of the smart way of Spark execution. That is the reason it will affect the total time, right?
Yes.
See, this is one of the reason I when I taken a class in a first session, I mentioned one point: 10 times, 100 times faster in memory, 10 times faster in disk. This mechanism is not there in MapReduce, right?
Correct.
This is one of the reason why Spark is 10 times faster in disk also. This is one of the reasons. There are many other reasons are there, but this is also one of the reasons. Okay.
Okay.
I think I hope I answered your question. Is any questions? Thanks. Yeah. Any questions or any advice? Because I got some time to talk to you today. So other than the Spark, if you have any open questions. Well, I think we don't have any questions. We'll wind up this call today. Guys, if you have any good material, people, I think you might take in some training, right? So if you have any good material, please try to pass on in WhatsApp or to my email ID directly, so that if I miss something in coming sessions, I will try to go through those topics and try to explain to everybody. Anybody has taken any coaching from any other institutes in this call? Nobody is taking?
No, Naresh.
Great.
No. For your classes and
you're depending only on my classes.
Sorry to interrupt you.
You are depending only my classes or Karnataka classes.
Yeah, Clever Studies classes and one more Karnataka classes. We were followed and we got job.
Okay, super. Thank you so much for your feedback. We're doing level based. I'm also working in another company, so it is very hard to me to get sometimes. I think I have to invest some at least half day or full day to memorize my skills or knowledge on the Spark, and then create these notes and to explain with you. Okay, and see, I think right. My intention is to give a clarity. I know many materials are available in YouTube or Google, but thing is, if you go and see 90% materials when we go to videos, they will understand. They are very gems, but coming to our point of view, we won't get that much clarity when we go to those videos. that personally experienced. So I want to, clear that wherever we are not understanding. I want to explain in a detailed manner, especially if it is possible like this, with the help of picture. If you see whatever you are seeing currently, these pictures you won't see anywhere. You won't see anywhere. This is drawn by me just few minutes before to understand you better. If I explain it my way in an air, what will happen? Definitely it will go in air only, right? Guys, that's it from my end. I will try my level best. And if you want to support me, please try to go through our videos. And I don't know, if you like the video, try to like it. No, that is small investment. You are not putting money from your pocket. Huh? Anyway, I'm I'm not doing all this for getting a likes. Okay, to give you some knowledge is our motto. But people are thinking to press the like button. They are giving some money to me. Okay, don't feel like that. It is free. Okay, YouTube won't charge you, right? Intention is when you click on like button, right? Like if likes are more, it may reach to many people, so that many people will get advantage. That is the only one, my concern. Otherwise, I'm least bothered about likes. Got it? All right, guys. Thank you. Have a nice weekend. All the best.
Thank you.
Thank you.
Thank you.
Thank you so much.